Welcome to the next lesson in this course, Refactoring to Clean Architecture. In one of the previous lessons, I mentioned that we should be able to treat each module as a standalone application, which also means that we can apply any architectural style that we think is a good fit for that particular module. So in this example, we could have one module using the clean architecture, another module using some variation of the vertical slice architecture, and the last module using the traditional three-layered architecture with an application, business, and data layer. However, there's nothing wrong with using the same architectural style across all of your modules, and there are a few good reasons why you might want to do this. The first reason would be standardizing how you develop all of your modules. In this example, I'm going to be applying the clean architecture to all of my modules, which means I can write a set of architectural tests that are going to help me enforce this architectural style, and I can apply the same set of tests to all of my modules, which makes it easier for me to add new modules in the future that conform to the architecture that I set in place, and it also helps me maintain the current architecture that I have in the existing modules. I'm going to assume that you are already familiar with implementing clean architecture in .NET, and if not, I have an existing course that covers this architecture in depth. It's called Pragmatic Clean Architecture, and I recommend that you watch that course because it's going to be an excellent complement to all of the topics that we cover in the Modular Monolith Architecture course. One more thing I want to comment on is the overlap between the vertical slice architecture and the clean architecture. I said that we are going to refactor from the vertical slice architecture to the clean architecture as part of this lesson. However, I don't think that these architectures are mutually exclusive. What I mean by this is you can still apply the clean architecture, which is a layered approach to organizing your application, and yet still benefit from the high cohesion that vertical slices bring. And the way that you do this is simply by applying the same vertical slices across your clean architecture layers. I'm going to show you how to do this as we move along in our implementation. We're also going to introduce another architectural decision that's going to impact how we're going to develop our application's use cases, and that is applying CQRS. CQRS stands for Command Query Responsibility Segregation, and we are going to apply this pattern to logically separate our application's writes from our application's reads. Let's say we have an incoming API request that is going to change something in our system. This is what we call a command. Commands mutate state. And how we are going to handle this is by creating a respective handler. We're going to be using domain-driven design tactical patterns, which means that we will be delegating our important business logic to the domain layer in the clean architecture. We're also going to be using EF Core for our entity repositories that are going to help us load the entities into memory, and we're also going to leverage EF Core change tracking to persist any changes into the database. This approach is particularly powerful when we introduce the concept of domain events and later the outbox pattern, but I don't want to overwhelm you with too much information right from the start. On the query side, we're going to have a much more simplified flow. We're going to define a query object that's going to have a respective handler, and this handler is going to go straight to the database and give us back the result that we are looking for. You have a lot of options in how you can implement the query handlers. I will be using Dapr and writing SQL queries because this is a very performant approach, but this isn't the only approach. You can also use EF Core directly and write LINQ queries. You can even have a separate database that is dedicated to containing your read models, and you can query that database directly. And this doesn't even have to be a SQL database. It could be a document database, as I'm going to show you later in the course when we introduce MongoDB. And now let's head over into the code and start refactoring our implementation. This is the current state of the events module from the end of the previous lesson. We implemented two use cases for creating and getting an event, and we organized our code into a feature folder by applying vertical slice architecture with two vertical slices containing our use cases. We also have our domain entities and response objects in the same feature folder. So let's start to refactor this towards clean architecture, and I will start by introducing the clean architecture projects. The first project is going to be our domain project. So let me create another class library, and I'm going to follow the same naming convention that I put in place for all of my modules, which is Evently, Modules, and then the name of the current module, which is Events, and then I'm going to assign the specific layer of the clean architecture that I'm creating, in this case the domain. This is going to be a .NET 8 project, and let's go ahead and create it. Now I'm going to pick up the pace and add 3 more projects for the other layers that I'm going to need. So the next one is going to be application. Let's go ahead and create that one. Then we're going to need one more project for the infrastructure layer. So let's create the infrastructure project. It's also going to be on .NET 8. And let's add one more project, which is going to be our presentation layer. This project will be responsible for holding our API endpoints. And it's also going to be a .NET 8 project. Now I'm going to get rid of these default classes and let's organize the project references. So the application project should be able to reference our domain project. So let's go ahead and add that. Then the infrastructure project will need to reference both the presentation so that it can register the API endpoints and the application layer because it will be taking care of any service registrations with dependency injection. And then the presentation layer will need a reference to our application project because this is where our use cases are going to live. If you recall from our initial setup, we also configured some default values for the target framework, implicit usings, and nullable reference types in our directory build props file, which means I can simplify the project files of my clean architecture layers. So that's what I'm going to do. And I can get rid of all of these property groups and just leave my project files containing the references to the other layers in the application. And now what we need to do is to start moving some files around. So let's start with the domain layer that's going to contain my domain entities. I want to create a respective folder inside that's going to contain my events aggregate, and this is where my event entity and event status are going to live. So I'm going to cut them out of my API project and move them into the domain layer. If we open up these projects, you can see that everything is fine. They are compiling. One more improvement I can make is to adjust the namespaces, and ReSharper has a very nice refactoring for this. So that's what I'm going to do. Let's close this down and let's see what the next step is going to be. My two use cases, the create event and the get event use case, which are complaining right now that they cannot compile, and we're going to fix this, are going to live inside of the application layer. So let me take the two use cases. I will create a respective event feature folder in the application layer, and let's move the two use cases. We also need to bring with us the event response because it's required for the get event use case. And now I can get rid of the empty events folder in the API project. What about the events module class, the tags, and our database context? I'm going to move these to the presentation and infrastructure projects respectively. So let's take out the tags because they are the simplest and move them into presentation. And then I'm going to grab the events module and the database folder containing our database context and the migrations and move them into infrastructure. Now we need to make a few adjustments. We're going to take the framework reference from our API project and add it to the presentation layer because this is where our API endpoints are going to live. So it's going to need the framework reference to ASP.NET Core. And then our infrastructure project is going to need the NuGet packages for working with EF Core. So let's go ahead and introduce that. Now if I go back to the events module, everything should compile, which is the case, but we have some other problems that we need to fix. If I head over to the application project where we have our use cases, now I can add a reference to my domain entity, which is great. However, I don't have a reference to the endpoint route builder or the events database context. And this is because they are not part of the application layer. So here's what we are going to do. I will take the get event and create event use case and make a respective copy in the presentation layer. I'm doing this to preserve the endpoint registrations, which I'm going to place in the events folder. The copies inside of the presentation layer are going to be very simplified. There will be nothing related to the use cases. They are actually going to be sending a command or a query which is going to be handled in the application layer. But as I said, I'm making this copy just to make our job a bit simpler. Let's go to the create event use case first and fix that one. I'm going to introduce a NuGet package to my application project, and let me go ahead and install Mediator. This is what's going to allow us to implement CQRS using the Mediator pattern. We're going to define our request objects, which are going to be commands or queries, and they're going to be handled by a respective handler. So because this is the create event use case, let's go ahead and create a respective command. So I will create a public sealed record create event command. And for now, let's make it empty. And this is going to be an iRequest object, which is an interface from Mediator for how we can define a Mediator request. And it's going to return, let's say, a GUID representing the identifier of the newly created event. With our command in place, I can now go to my create event endpoint and make a few adjustments here. We will leave the request in place, and instead of the events database context, I'm going to add a reference to iSender. This is an interface from Mediator. Now I'm going to do a refactoring on my use cases folder to make them scoped to the application layer. And I'm going to add a using statement so that I can reference the iSender interface. Now with this interface in place, I can go ahead and turn my request into a respective command object. So let's create our command, and this is going to be a new create event command. Then what we are going to do is to send this command using the iSender, so I can pass in a command object, and what we are going to get back is a GUID value representing our event ID. Then I can go ahead and take this event ID and return it from my endpoint and get rid of all of this logic that was actually implementing our use case. And this is all that is left inside of our endpoint. The endpoint is responsible for taking in a request object, turning it into a respective command, and then sending that command and returning the result. The endpoints are going to be very thin, and most of the logic is going to live inside of our handlers. Now, I also need to pass the values from my request object to the create event command. So let's pass in the request title, the description, the location, the start set, and the end set date. These properties currently do not exist on my command, so I'm going to go ahead and define them. So we need a title, we need a description, we need a location, and we need two date time objects for the starts at UTC property and a nullable date time object for the ends at UTC property. So with this constructor in place, our endpoint should finally compile and everything looks great on this end. Let's also do the same for the get event use case. Here, I'm going to create a query object. There's going to be another record. Let's call it get event query. And this is going to have one property representing the event ID of the event that I want to get from this query. It's also going to implement iRequest, and it will return an event response as the result of this query. Now, because the event could not exist, we're going to make this a nullable type. Now, if I go back to my endpoint, we're going to use the same approach of referencing iSender from Mediator. And here, I can go ahead and send a new get event query. I can pass in the identifier of this event that I get from the route, and I'm going to get back a new event response. So let's call this the event. And now I can get rid of my EF port query that I had earlier, and this is what I'm left with inside of my endpoint. The next thing I want to do is to make my endpoints internal so that they are only available inside of my presentation assembly. And the reason for this is because I want to expose a separate static class that will be responsible for mapping my endpoints. So let's call this the event endpoints, and it's going to use the same approach, but it's just going to group the respective endpoints that are related to events. So let's call this the map endpoints method. It's going to accept an iEndpoint route builder, so same as before. And all it's going to do is take the create event endpoint, call map endpoint on this, and pass in the endpoint route builder. And we're going to do the same for the get event endpoint. I'm also going to refactor this to adjust the namespaces for my endpoints. And now I can go to my events module where I was referencing my endpoints, and all I have to do is reference the event endpoints class, call the map endpoints method, and pass in the endpoint route builder. This will make it slightly easier for me to introduce